Hello everyone. In this chapter we're going to be talking about embedded operating systems and the Internet of Things and how it affects the cybersecurity world and topics you might be interested in. In the chapter reading, it's going to talk about essentially what embedded operating systems are, where they're used. It's going to talk about the Internet of Things. The chapter specifically talks about Windows IoT. And again, when I say IoT, I'm referring to the Internet of Things and other embedded operating systems. We're going to talk about vulnerabilities of embedded operating systems and best practices for protecting them. And when we talk about the Internet of Things, that's really a more modern term to talk about really any device that enables different modules or different industrial applications or typically non-digitized applications to communicate over a network. So we talk about light bulbs, we talk about HVAC systems, so heating and cooling. We talk about trash cans, toilet paper dispenser sensors, anything and everything that traditionally wouldn't be connected to a network, so not your traditional computer, a sensor or an application that is then enabled for network communication, data collection. So that's IoT. It's a fancy word around throwing a computer in something. So what are embedded operating systems? Essentially, it's an operating system that's for the most part, slimmed down so it can fit on a smaller device. And when I say smaller device, we're talking about less RAM, less storage space, possibly slower communication, a slower processor. They can be built efficiently, cheaply, and quickly, and then used to enable, again, devices to communicate and distribute their data over a network. And again, it's small. It's here again, stripped down version of an operating system, and it's very efficient. So a RTOS or real-time operating system, that's an operating system that has a guarantee of data. So when you think about thermostats or spacecraft, so these are operating systems where you need to ensure that you will get data, that the OS is fault protected, that it will constantly give you correct data, and the real-time operating system is used for those applications. Corporate buildings oftentimes, again, use lots of Internet of Things devices, especially as they upgrade to newer building management and building automation systems. You see your traditional computers and server rooms, etc. in there. A lot of those use embedded systems, but now we're seeing basically anything and everything in a corporate setting become IoT, become connected to a network. And embedded systems have always been in networks. Embedded systems are in your routers, even your home router. When we talk about DDworks and some of the RealTime Linux OSs, those are in devices that you have at your own home. They're used in firewalls. They're used in many applications. But again, as traditionally non-connected applications are moving towards connectivity, this is where we're seeing more embedded systems and more devices. So firmware reverse engineering, though, is somewhat new. Again, embedded OSs haven't always been a target until more recently. And the goal is when you have an embedded OS, a lot of times it's placed on the firmware itself. So it's very important from a hacking perspective to understand how firmware could be modified, chipsets could be modified, post factory install, post updates. How is the firmware receiving updates? How do we take over those channels? We need to understand how firmware might be affected in embedded operating systems and on embedded chipsets. So Windows embedded operating system reuses a lot of code of the main Windows Core OS. And this is great from an engineering perspective, but it's bad from a protection perspective. If you think about it, from an engineering standpoint, on Microsoft's side, it saves a lot of money to include the same code, so reuse, but at the same time, it also keeps them vulnerable to the same attacks that desktop and server OSs are vulnerable to. And more importantly, embedded operating systems aren't updated at the same frequency or at all compared to desktop and server OSs. So this makes it pretty vulnerable. Now, Windows CE, less relevant today because Windows 10 Core is becoming the centralized platform, but Windows CE code is available to the public to bring that whole open source model. Windows 10 IoT, when we talk about Windows 10 Core, again, it's a slimmed down version of Windows, but it provides the full Windows API without a desktop interface. Very much like Raspbian when we talk about Raspberry Pis, which are commonly used as IoT devices. VxWorks is another common embedded OS made by Wind River. It's used in a variety of applications and devices. So here's an example of creating an embedded OS image if you're going to build out a VxWorks image for an embedded device. F-35 Joint Strike Fighter, we've seen how many years that's taken to get off the ground. Greenhill Software supplies their embedded OS, obviously with security in mind and at top of mind. And QNX Software Systems, they do a commercial real-time OS that Logitech uses and Cisco uses as well. RTEMS, again, RealTime Executive for multiprocessor systems. It's an embedded OS used in space systems. Again, when we talk about real-time, ensuring the reliability, the confidentiality, the efficiency of data, real-time OSs, space applications are a great place for those. But when you're using, we talked about all these, when you use multiple embedded OSs, it significantly increases your attack surface. So you want to pick one and choose one. Here is an example of a monolithic kernel versus a micro kernel. So a monolithic kernel, again, you can think about that as your traditional kernel setup that would be on a desktop or server system where you have multiple layers, multiple modes. In a microkernel, again, all of this is compressed together. It's used mostly in industrial, medical, and consumer items. And it's, again, tailored for these cheaper devices. Again, we're buying in bulk here when we're purchasing this type of hardware, so we want to make sure we slim down the OS. And it can dynamically add and remove kernel modules. Unix-style embedded OSs, I talked about RealTime Linux earlier. Again, RealTime Linux is an example of an open-source real-time system. DDworks, you'll see this on a lot of routers. You can put it on most routers yourself. Here's a picture of DDworks. You've probably used it at some point. Again, when we talk about embedded OSs, a lot of them use the same code as full desktop and server OSs, and they're just as vulnerable, and you could argue in many cases more vulnerable because of the fact that they don't get updated that often. And again, when you're looking at profitability, if you want to take over the electrical system, the HVAC system of a company and hold it for ransom, if you want to shoot money out of an ATM, this is where you go, embedded OSs. They're in everything. Y2K software flaw. Older embedded OSs probably still have them, and on a regular basis they're being attacked. They're a high value target, not for only the things that they control, but also for their access to a broader network. And again, embedded OSs are networked. It's great that they're connected to a network. It reduces costs, reduces the amount of human capital that you need to maintain systems, but at the same time, they increase your overall attack footprint for the organization. Now, instead of having to hack into your server, get on, try to break through a VPN or go through an RDP channel, I can go through your heater, I can go through your air conditioner, and then gain access to your full network. So, as a security tester, you have to ask questions regarding security control sets. When you talk about PCI devices, so credit card transactions, point-of-sales machines, you have to ask, how are those connected to the network? How are they secured? Are they compliant? What level of PCI compliance do they have? You have to look at the whole supply chain, the whole value chain. Who wrote the code? Who made the chips? Supermicro was a great example where there was an accusation in Bloomberg Magazine, and God, I want to say it was 2018 or 2019, where there was supply chain claim that Supermicro, partially funded by Chinese government, dropped in a network snooper piece of hardware that sat on the network port and then relayed data back to somewhere else. That was never proven, but it got everybody up in arms. It's a great example of how the supply chain can be significantly affected. So again, you have to go through various controls, whether it be SOC, ISO 27001 and 2, PCI, DSS. You have to go through the various control sets to ensure your embedded OSs are compliant with your security standards. And again, they're difficult to patch. Why? Well, think about it this way. If you have an HVAC controller, it's probably in a wall or in a ceiling somewhere. There probably isn't an accessible port. It's not just a regular computer. Maybe you have to have a proprietary cable. Maybe you have to have a certification or special manufacturer access to update those systems. They're just difficult. And when difficulty presents itself, companies just choose not to update. Individuals just choose not to update. It's a complete pain in the butt. Why do I have to do it? So a lot of times this makes it very difficult to secure from an organizational standpoint if they traditionally haven't been updated or can't be updated, especially in older systems. So you have to look at other options, firewalls, network segmentation. Get these things off of your network or in isolation. If you aren't able to patch it, you need to make sure it's controlled. This is where the benefit of open source software comes in terms of embedded OSs. You have the weight of the community behind you instead of the decision of a corporation of whether or not to deploy a patch. Using the Linux kernel has flexibility and support, but at the same time, being open source gives everyone the chance to find vulnerabilities, and people may or may not report them. Networking devices oftentimes have embedded OSs, and this is where some big problems come in. If you have a router or a switch or a firewall which is implementing some of these embedded OSs, and these are not patched for flaws and their firmwares are not updated, this is where you run into an instance where if you gain control of this device, you can gain control of the network. So you need to make sure that not only are you controlling and patching and having a security plan around the general embedded devices on your network that control your heaters and your electrical system and your coolings and your chillers, you also need to make sure that all your networking devices are regularly updated, that firmware is regularly updated, because these devices control your network. There's many vulnerabilities. Authentication bypass is a common one. And again, when we talk about bypassing authentication, this is a launching point for getting in the rest of your network. Printers, scanners, copiers, and fax devices. These are other devices, again, that use embedded OSs. You go search Shodan or search Census, you're going to find open HP printers, Brother printers, scanners, copiers all over the place. And again, this is an entry point into the network. If you're leaving this stuff open on the internet, you're leaving yourself vulnerable, you're increasing your security footprint, and you're beholden to whether or not those systems are properly patched. On multifunction devices, again, may have information that is sensitive on them, and you need to make sure that those are patched and protected. So here's an example of a Dell laser printer. And oftentimes you'll still see these posted on the internet. It's crazy. And this is an example of updating the firmware. And again, this can be a complete pain in the butt, considering that you have to go through all these IT devices and use their manufacturer-specific firmware update path. And a lot of times this is why you will not see some of these updated all the time and vulnerable and open to attack. So SCADA systems, supervisory control and data acquisition systems, this is for large industry. So when you talk about manufacturing, when you talk about your water plants, your sewage plants, electrical facilities, airports, baggage handling systems, those are things that I have experience with. This is where you run into problems. All these devices run off of PLCs, have embedded systems, they have operating systems on it, and they all need to be updated. And some of the best, kind of the best first layer of defense is air gapping SCADA systems. Don't connect them to the internet, don't connect them to your network, keep them separate. But again, as we saw through the alleged attack on Iranian nuclear facilities, that air gap doesn't matter, right? As long as you have human beings traversing that air gap, you still are at risk. There's another example of a Ukrainian power plant. Won't say who attacked it, but again left bunch of people out of power. Why? Because it was an attacker, a state-sponsored attacker, allegedly, going into a SCADA system to stop the power flow. Cell phones are great too, but again, still cell phones are open to attack. Stingray 2, they're cool pieces of equipment. It'll be, if you're lucky at some point, you get to play with one. But again, it usually requires a warrant. There is inherent security that people believe cell phones have, but it's not necessarily true. There's plenty of vulnerabilities in cell phones themselves and in the communication protocols, how cell phones decide on a tower, how cell phones essentially can switch between towers, nearest neighbor, things like that. Need to be concerned. Just because you put your IoT device on a cellular router doesn't inherently make it safe. We've talked about rootkits. It's part of the other chapters, but again, the goal of rootkits is to modify the operating system. Oftentimes they do this as drivers or kernel mode modules. They're in every major operating system, and they're in embedded operating systems too. But again, here, this is where a rootkit can get access to firmware to modify that firmware. TPMs are a good defense around low-level rootkits. It tries to ensure that the operating system is still in the state that it was intended to be in. But firmware rootkits are hard to detect. Since it's the firmware itself checking for the rootkit, can you trust the answer? And then we talked about insider hacking here. This is code hidden in flash memory. You also need to know that when we talk about rootkits, and I talked about Supermicro before, are your devices compromised before they're even purchased? Who had access to the devices? Who had access to write firmware to the devices? When you get a new device, you should wipe it clean. It's a good practice. And we mentioned here LoJack for laptops. I don't know if they're trying to sell it, but it's a theft recovery device. So best practices for embedding operating systems. Make sure all your operating systems in an organization that are embedded are identified. Prioritize which ones are required for business continuity. Follow least privilege. Update. Make sure they're all patched. Make sure you're using cryptographic measures. Ask the question, is your data encrypted in motion at rest? Is it stored on those devices for any period of time? Make sure you're following the manufacturer's recommendations, and make sure network access is restricted. Are there ways that you can air-gap these things? Do you need to isolate them using VLANs? How do you control communications? And then make sure the network devices themselves are monitored for the same quality settings. Again, we talk about what an embedded system is. We talk about real-time OSs and how corporate networks have numerous embedded systems and can be extremely vulnerable and really increase their security footprint if they don't have a plan in place on how to manage those embedded systems. Microsoft has offered IoT systems for a long time. Windows CE, Windows Mobile, now Windows 10 IoT is the most modern version. We talked about monolithic kernels versus microkernels. And again, there's Unix and Linux-based embedded OSs that compete with many of the proprietary systems, and there's pros and cons, benefits and drawbacks to using embedded operating systems that are Linux-based or open source. Vulnerabilities are often overlooked in embedded OSs, mainly because, again, the patching scenario is rough. If you have 50 different manufacturers, 100 different models of IoT devices, you may have, 50 or 100 different ways of patching them, and it can become untenable. You need to start bringing in full-time staff to just manage that on a regular basis. Embedded systems are everywhere, including network devices. Make sure your network devices are updated. In SCADA systems, this is where the public interest comes in. This is where we talk about critical infrastructure. You need to make sure these systems are secure because it can have an effect not only on an organization, but people. This is when we talk about, this is where hackers can harm human beings. When we talk about dams, water treatment facilities, sewer treatment facilities, electrical facilities, nuclear facilities, all of these use SCADA systems, and you have to keep them controlled. Smartphones and PDAs, again, you have to keep these controlled as well. They include embedded operating systems. And don't think just because you connect an IoT device through a cellular router that it is secure. Cell phone networks can be overrun. Again, firmware, rootkits, super hard to find. Again, when you're depending on the firmware itself to report whether or not it has been compromised and there's a rootkit on the firmware, who do you trust? You don't know. Best practices, make sure they're followed. It ensures security. Follow the manufacturer's guidelines. Regularly patch your embedded systems. Make sure that you have a plan in place. Evaluate risk. Look at what devices could cause problems, which ones don't. Again, always take cybersecurity from a risk-based perspective. Just don't look at cybersecurity as just an IT function, but it's a corporate function, a business function. In order to properly build out a risk register and prioritize which items should be fixed, what should be patched, what is the patch cycle, you need to determine how much of a priority an individual system is to overall business continuity. So just remember that, because it can become a problem when you have thousands or tens of thousands of these devices in a corporate setting. That's all for this week.